Hello, wonderful students. How are you doing today? Hopefully you're doing great. We're going to go ahead and begin review of standards 9C, 10A, 10C, and 11B. Remembering the last two standards are the ones that are required. So let's begin. For standard 9C, solving and applying quadratic inequalities, there are a couple of things that we need to remember. The first one is if it's going to be a closed dot, that is only for less than or equal to or greater than or equal to. Basically, it includes the solution if it's equal to. Then the second type of solution could be that it isn't a solution really, that it's open. So notice the circles or the dots can either be open or closed. It's open if it's greater than or less than. Something to keep in mind. Okay, so for this first question we can see that it's going to be an open circle since it's a greater than symbol, while for letter B it's going to be a closed dot since it's, or a closed circle since it's equal to as well. So for letter A, let's begin. I'm going to solve by getting x by itself. The first thing I'm going to do is I'm going to add 2 to both sides. So check that you did that. The next step is we are going to get 108 on the right side. I will not take the square root yet because there still is a 3 there. So I'm going to divide out the 3. The reason why I do that is the opposite of multiplication is division, so I'm going to go ahead and get rid of the 3 that way. 108 divided by 3.
The answer is 36.
So we get x plus 4 squared is greater than 36. At this point you could also just change it to an equal sign so you know that you're just solving for something called your boundary points. That's really all we're doing when we're solving an equation or inequality like this, is you're getting your boundary points and deciding whether your solutions are on the outside, facing right or left, or in the inside, or other. So our next step here is we're going to go ahead and take the square root. That's going to get rid of the square. That leaves us with x plus 4 is, at this point I'm just going to say equals plus or minus 6. The square root of 36 is 6, and when we take the square root we're going to get plus or minus. Why did I change it from a greater than to an equal sign? Again, we're just solving for our boundary points. So finally I'm going to go ahead and subtract 4 to both sides, and that leaves me with 2 solutions. X equals negative 4 plus or minus 6. So we're going to get negative 4 plus 6. That's going to be x is 2. That's our first boundary point. And our second boundary point is going to be negative 4 minus 6, which is negative 10. So I'm not sure if these numbers were going to fit on my number line, but let's see how many dashes that are here. 1, 2, 3, 4, 5, 6, 7. Yeah, it's definitely going to fit. So I'm just going to put negative 10 all the way on here on the left with an open circle. And I'm going to put another dot at 0. Let's see, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And our other solution, or boundary point, sorry, at positive 2. So we're going to get either our answers are in region A and C, or our answer is in region B. Now, which one is it? Now, remember, there is a little trick I did show that pretty much every time, if it's greater than, it's going to be thumbs out. greater than or equal to. It's going to be thumbs out. But I'm going to just double check that my answer really is in region, thumbs out is region A and C. But I'm going to double check that that really is my solution. So what I can do is I can check if this point 0 is a solution or not. Because if 0 is not a solution, we know the answers are going to be in region C and not B. So I'm going to go ahead and test 0. So the way that I do that is I go back to our original inequality. Or a simplified version of it. And I'm going to plug in the easiest, or substitute the easiest number into this. The easiest number to substitute in tends to be 0. So if I plug in 0, I will get 0 plus 4. And all we have to decide is whether this is a true statement or not. So I will get 3 times 4 squared. 4 squared is 16. And 16 minus 2, is all this greater than 106? The answer is, it is not. So 3 times 16 minus 2, that's just not bigger than 106. So the answer of 0 is not a solution, meaning our solutions will be in region C, everything bigger than 2, and it'll also be in region A, which is anything less than -10. So that's one way to write our answer. The other way to write our answer is going to be x is less than -10, or x is greater than 2. Now, just like we tested 0, we can also test a number here in region C, like for example 5 or 10. And we can also test a number that's in region A. But since I know it's not region B, it is going to be thumbs out. Okay, so keep in mind, greater than or equal to is going to be thumbs out. Let's move on. So that was my answer. All right, for number or letter B, my first goal is to see if there is any way to solve it immediately. I can go ahead and do that, but for this one I'm going to go ahead and make sure that it's equal to 0. So I'm going to go ahead and subtract 27x. I'll put it right here in the middle. Okay, so that gives us 5x squared minus 27x plus 10. It's quadratic. Remember, it's quadratic, so we know that it's very likely going to be 2 solutions. So at this point, I could use multiple methods. The first method I could use is factoring. That's a lot of our go-to methods, is factoring. You can also use the quadratic formula, or you can complete the square, which I'd probably I don't think I would do that at all in this case. And you can also try to graph it. You know, you can graph it to see what your x-intercepts are. But in this case, I'm going to go ahead and solve it using factoring. Factoring is very important. So I'm going to go ahead and show us how it's done, how to factor. Okay, so I'm going to use the X box method for factoring here. On the top of my box, I need to multiply 10 and 5, x squared. That gives me 50x squared. And on my bottom box, I'm going to put negative 27x. At the same time, I'm going to go ahead and make sure all of these numbers go in our box here. We have 5x squared. We have 10 here. And then the negative 27x, we need to split that into 2 boxes. So we have to decide what multiplies to give us 50 and what adds to give us negative 27. So the answer right away, I can see that it's going to be negative 25 and also 2. Those two numbers multiply to 50 and they also add to negative 27. So I'm going to put those numbers in my area model, my box, in no particular order. As long as it's going in the box, we're going to get our answers. So at this point, I do want to factor. I want to see what my outside area would be. So I'm going to, let me zoom out a little bit here, sorry about that. I'm going to go ahead and get my outside values. So it's going to be the common factor of 5x squared and negative 2x is just x. This is going to be 5x since they have in common a 5 and an x. This would be negative 2. And this would also be, well, this would be negative 5. So factored version of this will give us x minus 5 and 5x minus 2. And I'll just say equals 0, because realistically all we're trying to do is find out our boundary points. All right, at this point, again, you could have used the quadratic formula. The quadratic formula does solve these. In a way, it does get your answer a little quicker. But I'm going to go ahead and continue factoring and solving using the zero product property. So we know just by switching the signs, our first answer is 5, but I'm going to show my work for that. X minus 5 equals 0, or 5x minus 2 equals 0. So we get x equals 5 as our first boundary point. And solving this, I will get 5x equals 2, divide by 5. We get our second solution, which is 2/5. X equals 2/5, which is, if you divide those two numbers, you'll get 0.4. So I'm going to plot those two numbers on my number line. Might as well call this 0 here. 1, 2, 3, 4, 5 will be right there. Open or closed? Now look at the symbol. So it's going to be a closed dot on 5 and a closed dot on 0.4. 0.4 is right about there. Okay. Now, our next task is, we do remember there is some trick for this. If you do want to use the trick, feel free to try that out. This one was thumbs in. Sorry, this one was thumbs out since it's greater. Thumbs out. But this one, it's going to be thumbs in, or region B, since it's less than or equal to. So just to show that one more time, remember it's thumbs out in region A and C if it's greater than, but if it's less than or less than or equal to, then it's going to be thumbs in what we call region B. Okay, so I know my solutions are going to lie between 0.4 and 5 in this region, region B. While region A and region C would not include solutions. Now, how can you check? Again, maybe you can check by just plugging in a number in region C. I think a great number to try out would be possibly maybe 100 or even 1,000. You could plug in really big numbers. You can also try 0. 0 would be a very easy number to test. We can go and show that here. If we plug in 0, we get 0 plus 10 is less than 0. Is 10 less than 0? Nope. So 0 is not a solution. We can also plug in a number like 10. If we plug in the number 10, 27 times 10 is going to be 270. And if I do this, this would actually be 10 squared is 100. 100 times 5 is 500. And 500 plus 10, is that less than 270? The answer is no. So if you plug in numbers in region A or in region C, they're not going to be solutions. So our answers lie between the numbers 0.4 and 5. So we can write our answer like this. They lie between 0.4 and 5. Okay, our next problem is letter C. For letter C, you can decide if you want to distribute and solve it a different way. For this one, I'm going to use a little bit of a trick, which is I'm going to multiply by the opposite of 3/4. The opposite of 3/4 is 4/3. So if I do that, it's going to cancel out. That's going to give me x minus 5 is greater than whatever this multiplies to. Let's see what it multiplies to. Negative 6 times 4/3.
It's approximately negative 7.9999.
It's a little strange, but let's try to get a different way. Negative 6 times 4 divided by 3.
The answer is negative 8.
That's more like it. So the answer here on the right side would be negative 8. Now at this point, I'm very confident that we can just go ahead and add 5 and get our solution set. So we have x is greater than negative 3. So graphing that, we can put 0 here. We can put negative 3 right about there. We're going to use an open circle since it's greater than, and we're going to face it to the right since it's greater than. It's greater than negative 3, so that would be our solution. X is greater than negative 3. Be sure to test your answers. You know, if you can plug in 0 and get a true statement, that would be great. So plug in numbers in here and check your work, but for this one I'm very confident that that's the answer. Okay, for the next one I'm going to solve this perhaps in a unique way. I could take the square root right now, but I'm actually going to do it in a different way. So my first step for number or letter D is I will divide by 4. That gives us x squared is less than or equal to 9/4. I will take the square root. That cancels out the square. That'll give us x. At this point, I'm just going to solve for my boundary points. It's going to be plus or minus the square root of 9 over 4. Well, check this out. You could simplify this to plus or minus square root of 9 over the square root of 4. But what's the square root of 9? 3. And what's the square root of 4? 2. So we get our two boundary points at positive 3/2 and also our second boundary point at negative 3/2. These right here, again, I'll write it one more time just so we're not confused. These are our boundary points. So I'm going to circle that. That's not my answer. My answer needs to go on a number line and written in a slightly different way. So I'm going to graph these, maybe perhaps graph 0. 3/2 is about 1.5. Close dot. And negative 3/2 is negative 1.5. You can check your work. What's 3 divided by 2?
It's 1.5.
1.5. So that would be our two boundary points. Now, does our solutions lie in region A, or in region B, or in region C? This is very easy to test out. Go to your original inequality and plug in 0. 0 is in region B, so let's see if it's true. Four times 0, is that less than 9? The answer is yes. So region B is where our solutions lie. Every number in region B between the boundary points is a solution. Again, this one is it thumbs in or is it thumbs out? Right, so thumbs out would be greater than or less or greater than or equal to. Thumbs in would be less than or less than or equal to. So since the symbol shows that it's less than or equal to, we're going to know that the answer must lie in region B. So this is our answer, region A and region C. You can test them, but they're not going to be solutions. So finally, I'm going to write my answer in a different way. All the numbers lie between -3/2 and +3/2. I'll put x in the middle. This is between. Key B, between. And I'll face the inequalities the same way, and even the same way as my original inequality. That's our solution. Okay, next up is standard 10A. 10A, graphing and completing the square for equations of circles. So a couple important notes. We do have x minus h squared plus y minus k squared equals r squared. This is the equation in graphing form for all circles where h comma k is the center and r is the radius. And a second important note is how do you complete the square? Complete the square uses a formula b over 2 squared, if you want to use the formula. Okay, number 1. Step 1, I'm going to group the x's together. We get x squared minus 4x. And I'll add a box as a space. Also, I'm going to group the y's and I'll also add another box. And then if there's any floating numbers here on the left side, which there typically is, I'm going to go ahead and add that to the right side. So I'll add 4 to the right side. That leaves me with 4. But to balance our equation, I will also need to add the same box on the left to the right, the same green box here as well. I will add that. Whatever number I add, I'm also going to add it to the right side as well to balance the equation. Okay, so now I'm going to use the formula b over 2 squared. So I'm going to cut this b value in half, which would be -2, and I'm going to square it. So -2 times -2, that's 4. So again, cut it in half and then square it. So just like it's shaped like a square, we just need to multiply length times width to get -2 squared, which is 4. So if I add it to the left, I'll add it to the right, and now I'm going to do the same for the green. I'm going to cut 2 in half, and I'm going to square it. Now what's 1 squared? 1. There we go, adding it to both sides. Now this is the easy part. If you've done this, you're going to recognize that we can go ahead and factor this. Factoring that would just be getting us x minus 2. It's always half of that, since it's a perfect square. And let's do the same thing for the y's. We get y, well, what's half of 2? 1 squared. And then adding up all these numbers right here gives us 4 plus 4 plus 1 is 9. Now how great, we got our answer. X minus 2 squared plus y plus 1 squared equals 9 in just a few steps. Now what's the center? The center is we have to switch the symbols. If it's parentheses, we switch it. Why do we switch it? Because the formula also tells us that it has to be the opposite, or negative. So I'm going to go ahead and switch the -2 to a +2. I'll switch the +1 to a -1. Now the second thing is the radius squared. So whatever r squared is 9, what number squared is 9? We know that the answer is 3. So the radius must be 3. So if you're ever working backwards, you can just go ahead and take this number, 9, and just square root it. Square rooting it gives us the radius. Now we can graph this pretty quickly. The center is 2, -1 with a radius of 3. So from the center of our circle, we're going to go up 3, right 3, down 3, left 3, and that gives us a pretty great reference for what the circle looks like. Now, something to keep in mind, this dot isn't actually a solution. The circle is, but most of the time that dot in the middle is totally fine to be there. All right, next up is number 2. The center is labeled as -1, -2. The radius, we can just go ahead and find out how long the radius is. 1, 2, 3, 4. The radius is 4. So the equation of this circle must be, if I switch the sign, it'll give us x plus 1 for x. And for y, if I switch the sign, I'll get y plus 1. Oopsie, y plus 2. And then for the radius, I do have to square that. So if I square the radius, I will get 16. 4 squared is 16. So that answer would be the correct one. All right, next up is number 3. For the circle equation below, which one is true? So for this one, this is an interesting case where we actually don't have a y value. It's not moved up or down. Remember, this is left or right, horizontal. That's why it's h. This is vertical. I like to say vertical with a k. It's going up and down. So it's not going up, but it is going left. So this is going to be left 4 by switching the sign, and 0. It's either this one or this one. Now, which one is the radius? Right? If you square root this, you'll get the radius is actually 4. So our correct answer for this one should be letter C. C is the correct answer. Okay, finally, number 4. We can go ahead and graph this one, or look on the graph, see what's going on. The center is 3, -1. So if we switch the signs, it should be x minus 3 squared, y plus 1 squared, just by switching the signs, and then the radius squared. The radius appears to be, just count carefully, very carefully, 1, 2, 3, 4, 5. So if we 5 squared that, we'll get 25. So we're looking for something with a radius of 25. Cannot be this one, cannot be this. We're looking for -3, +1. So -3, +1 would be this guy. So letter B. Letter B is the correct answer for this one. And that wraps up the circles. Let's move on. Okay, next up is standard 10C, arcs, angles, sectors, and even things like this. So for this one, I'm going to I guess I'll just go ahead and begin. There's a few things we need to know about this. The first thing is we do have tangent lines. Tangent lines always touch a circle once. And if it does, it's going to always be perpendicular to the radius. So tangent lines are always perpendicular to the radius. We should also know that there's 360 degrees in a circle, and a few other things, but let's begin number 1. It says in this circle above, BA and BC are tangents. Okay. BA and BC, they're tangent lines, so if we wanted to, we can just continue the line. Those are tangent lines. But at this point, we should be like, yo, they're tangent lines, so we know that these need to be 90 degrees. Label them. Label them. So they're tangent to circle O at point A and C respectively. The measure of angle AOC is 142 as labeled. And we just need to calculate a few things about this. So the first one is going to be, what is the measure of BCO? BCO is angle C. BCO, we know it's 90 degrees since it's a tangent line. 90 degrees. Next up is angle B. Well, what shape do we have here? That shape is a quadrilateral. How many degrees are in a quadrilateral? A quadrilateral actually has 360 degrees as well. So since these add up to 180, these two must also add up to 180 degrees. So angle B and angle, in a way, O, or AOC, they both have to add up to 180 degrees. So doing a simple calculation, I'm going to get 180 minus 142 will give us what angle B is. 180 minus 142.
The answer is 38.
38 degrees. So remember, these two angles will always add up to 180 degrees. Okay, next up is the measure of arc AC. So I'll go ahead and label what arc AC is. Arc AC, or CA, is the same as the central angle. So whatever the central angle is, that arc is also the same. So that's going to be 142 degrees. Next up we have arc, or major arc, AQC. Major arc, these three letters. So AQC will be, well, everything in a circle adds up to 360. So since we have a major arc and a minor arc, we know that we're going to get 360 minus 142. 360 minus 142.
That would be 218.
218 would be the correct answer for that one. Okay, next up is to solve for the letter x. There is another sort of theorem we need to know, is that both of these tangent lines come from the same point, so the tangent lines have to be equal in length. So knowing that these two are equal in length, both BC and BA, we can go ahead and set them equal to each other. So 3x minus 6 equals 2x plus 1. So let's solve that one. Subtracting 2x, we're going to get our answer pretty quickly. I'm also going to go ahead and add 6 at the same time. So we're going to get our answer of x equals 7. X equals 7, just by setting these two equal to each other. Okay, next up is, what is the length of BA? BA is the tangent line right there. Tangent line segment. So we have to find out what the length of that. We know that x is 6. Oh, not 6. My apologies. X equals 7. So if I multiply 3 times x, which is 7, and subtract 6, I will get my answer. 3 times 7.
It's 21.
21 minus 6.
The answer is 15.
So the length of that segment right there is 15 units. 15 would be the correct answer. Okay, let's move on to number 2. Number 2, we need to know that this is the intersecting chord theorem. This and this will multiply and be equal to those two right there multiplied together. It's always that way. So if I multiply 2m times m plus 2, I'll use parentheses, it'll be equal to m times 3m minus 1, and I'll use parentheses there as well. Okay, I'm going to go ahead and solve this. I know I can do this by just distributing this and solving for m, which it says to do right there. So I'm going to go ahead and distribute, and solve. That's going to give me 2m times m. 2m times m is 2m squared. 2m times 2 is 4m. m times 3m is 3m squared. Uh-oh. And m times negative 1 is negative 1m. So we have this so far. Alright, now what I'm going to do is I'm going to try to solve by getting m either by itself, or I know this is quadratic, so it should be 2 solutions. Very likely going to be 2 solutions. But I'm going to go ahead and see how I can solve this. So I was actually shown 2 different ways to do this just earlier by a visiting student, and they told me that the teacher showed one way and they figured it out a different way, which is totally fine. So I'm going to go ahead and show both ways. Well, first let's get the m squareds together. I'm going to go ahead and subtract 2m squared, and I'll put the m's together as well. So I'm going to get, just by adding m and adding m, I'll get 5m equals m squared. At this point is where we were a little stuck, but at this point we can go ahead and show that there's actually 2 different ways to figure this out. The first way is to check this out. Divide by m. If you divide by m, that gives us the answer pretty quickly. We get 5 equals, well, m squared divided by m, that's just m. Boom. The second way to figure this out is by setting it equal to 0, just like we would a quadratic. It is quadratic, so there should be 2 solutions. So by subtracting 5m, we get 0 equals m squared minus 5m. At this point I can use the quadratic formula or factor. I'm going to go ahead and factor since I know they have an m in common. It'll be m times m minus 5, just by factoring. And by using the zero product property, I'm going to get m equals 0 as one solution. And by switching the signs of this one, I'm going to get m equals 5 as my second solution. Now, check this out. If I did it this way, I would have one solution. It's quadratic, though. It's a strange case. If I do it this way, I'll have 2 solutions. So my answer is m equals 0 and m equals 5. But Please check your work. Does an answer of 0 make sense for this situation? Basically, if we set m equals 0, could the length of this guy be 0? Impossible. Could the length of this guy be 5? Yes. Now we're talking. So the real answer, even if you did it this way, you kind of lucked out. The only answer is 5 for that one. All right, letter B. Letter B says to find the length of all of chord AB. So we're going to go ahead and add m plus 2 and also 2m. But what's m? M is 5. We're going to get 5 plus 2 plus 2 times 5, which is 7 plus 10, which is 17. All right, number 3. Number 3 is pretty far off from what the test is actually, so for this one, I'm going to go ahead and call that one a day. There is a way to do this one. It actually involves knowing that this is a right triangle, and it is actually a 30, 60, 90. The length of this side is 5. The whole hypotenuse there would be 10. So this one is really comparable to a 30, 60, 90 right triangle. We get 1 root 3, 2. So this would be 5 root 3. And this would be a 30, 60, 90. Just by knowing that these are similar by a scale factor of 5. You could have also used inverse trigonometry to figure out the angles, because you need these angles. But this is too much. Too much is going on, so we're going to leave number 3. Nothing like number 3 is on the test. We're going to leave number 3 to the side now. And let's turn to what appears to be the last standard. Let me double check. Oh yeah, so some of these standards go by pretty quickly. Others might go by a lot slower. So we're on our last standard, which is 11B. 11B uses a lot of formulas, so hopefully we can pick up another formula today and recognize that some of these shapes do have some complicated things going on for them. So for this one, I do want to keep in mind that we are very often going to be using the Pythagorean theorem. Why? Because there's going to be triangles in these shapes. So if we're going to use the Pythagorean theorem, very likely the teachers are going to be saving you some time, sometimes, where it's going to be a 3, 4, 5 Pythagorean triple, possibly a 5, 12, 13. There are others like 8, 15, 17, 7, 24, 25. There are others like that. Remember, you could also multiply by 2 and get 6, 8, 10. These are all Pythagorean triples. But these are the main 2 things that you should pick up when solving for the volume of shapes that are similar to these ones. Also, it does have an apex, so there are going to be triangles often in these shapes, and you are going to be having some interesting formulas as well. So keep that in mind as we begin standard 11B. So 11B number 1 says to calculate the volume of the following square pyramid. First, it says we should find the value of h. So since it says that, why don't we just go ahead and solve for the value of h? The value of h is not given to us, so we are going to use the fact that we can actually build a right triangle. What kind of triangle? Yeah, a right triangle. So I'm going to need to use the Pythagorean theorem. This length right here is given as 13. It's actually the slant height. We have the length of the base of that triangle would be 5, since it's half of 10 would be 5. And therefore, remember, there are some Pythagorean triples. This is a 5, 12, 13. So real quick, we can figure out that the height would be 12. So h we can label as 12. Now, why do we need this h? Because this 12 really is the height. Well, this one's a slant height. We can't really use either number because guess what? They're different, right? The height tends to be shorter than the slant height. So make sure you're always using the correct heights for the formulas. Okay, so now what's the formula for the volume of a pyramid? Well, since it has an apex, we know it's going to be 1/3 the area of the base times the height. Not the slant height. The height. So we're going to get our volume is 1/3. What's the area of the base? The base shape is a square. We do have a 10 by 10 square. The area of a 10 by 10 square is length times width, which is, I'll just go ahead and write this down as 10 by 10. Length times width. And we also need to multiply by the height of the shape. So the height of the 3D figure happens to be 12. So I need to multiply those values there, right there, giving us 1/3 times 10 times 10 times 12. That's going to be, I believe, yeah, 400 centimeters cubed. Now you might be wondering how to do that so quickly, or maybe you can do it a lot quicker than I can. But 1/3 of 12, if I combine those, 1/3 of 12 is 4. And 4 times 100 is 400. So that answer gives us the volume of 400 centimeters cubed. Okay, next step is number 2. Find the surface area of the following tennis ball to the nearest hundredth. So for the surface area, it's going to be using a formula for spheres. Surface area formula is 4 pi r squared, where r is going to be the only factor we need. R is the radius. So we just need the radius. Well, we're given the diameter. The diameter is the full length of the circle. We only need the radius. The radius would be half of that. So half of 2.6. What is half of 2.6?
It's 1.3.
We get 1.3. So calculating the surface area, I'll write it right here since it's pretty quick. Surface area of a sphere is 4 pi r squared, which would be 4 times pi times 1.3. Don't use 2.6 because that's not the radius. 1.3 squared, giving us an answer pretty quickly. What is 1.3 squared?
That would be approximately 1.69.
What is 1.69 times 4?
It's 6.76.
We get 6.76 times pi. That's called our exact answer. 6.76 times pi.
It's approximately 21.2371.
So 21.2371 would give us approximately 21.24 inches squared when we round to the nearest hundredth, or the nearest 2 decimal places. Again, the first is exact. 6.76 pi is great answer. It's a perfect answer. It's exact. But approximately, this is going to be 21.24, and that's inches squared. Okay, let's move on. Number 3 is going to be the volume of a cone. So the volume of a cone, it does have an apex, so we're talking about the same formula. Volume of a cone is going to be 1/3 base area, which we know this is a circle, and that is going to be multiplied by the vertical height. So what's the area of a circle? We need the base area, so we're going to get an actual simplified formula, or bigger formula, of 1/3. The area of a circle is pi r squared, and we know h is just the height. Great news, the height is given to us. It's 8. The only thing that's not given to us is the radius. So we need the radius, and we know the height actually appears to be 8 inches. Okay, so let's multiply, let's figure out what the radius is, and then we can use our formula to calculate what the volume is. So for number 3, we have to use the fact that this right here is a right triangle. Really truly is a right triangle, so I'm going to use the Pythagorean theorem to solve for the missing side, which is the radius. I'll label it. Okay, I'm going to go back to the fact that we do have some Pythagorean triples. This is a 3, 4, 5 doubled. 3, 4, 5 times 2 is 6, so I know right away that my radius is, since it is a 6, 8, 10, or 3, 4, 5 Pythagorean triple, the answer must be 6. But if you didn't figure it out using Pythagorean triples, you can also just do a squared plus b squared equals c squared, where a is, you can say, the radius, b is 8, and c, which is, you of course know, c is always the hypotenuse, or in this case the slant height. C in this case would be 10. So solving this, you can get your answer of r equals 6 as well. So the radius, which we need for the formula, is 6. So we're going to calculate the volume now. The volume of the cone is 1/3 times pi times 6 squared times h. The h is the height of the shape, the vertical height, which we know is 8. So I need to multiply all of these values together to get me my answer for the volume of this cone. So I'm going to go ahead and multiply this out. Simplifying this, I'll get 1/3 pi times 36 times 8. 6 squared is 36. Now I can try to multiply this as best as I can. First in my head, 36 times 1/3, I know that's 12. 12 times 8, I think it's 96. I'm going to double check. 12 times 8.
The answer is 96.
Yes. So we get 96 times pi, or just double check your answer here. 1/3 times 36 times 8.
That would be approximately 95.9999.
It really is 96. And then don't forget about pi. So this is going to be our exact answer. But approximately that's going to be 96 times pi.
That would be approximately 301.5928.
And that's how we got the answer for volume, 301.559 inches cubed. Okay, finally we're going to just do the surface area formula for a cone. The surface area for a cone does have a very interesting and unique formula. It's going to be the area of the circle plus the area of the lateral surface area. The lateral surface area actually needs to be a sector. If you've ever opened up a party hat, this actually would be a sector. So it's going to give us just an interesting formula. Pi r squared plus pi rl. Now we know r, which we already calculated, is 6. And L is going to be the slant height, which we know, I'll write it again. The slant height in this case is 10. So this formula does actually simplify. You could also do pi times r plus, multiplied by r plus L. This is a formula that a lot of people will use just because it's a little simpler. But either of these formulas will get you your answer. If you multiply pi times the radius is 6. The radius again is 6. The slant height is 10. If you do this, or if you do this one, either way, pi times 6 squared plus pi times 6 times L, which is the slant height, which is 10. Either of these two formulas will get you the answer in just a matter of moments. So we're going to go ahead and multiply this out. We get 6 times pi multiplied by 16. 16 times 6.
The answer is 96.
We'll get 96 pi. And that actually, the surface area is the same answer as the volume. Is this always the case where the surface area is equal to the volume? No. Surface area does not always equal the volume. It's a very rare case, but in this case, 96 times pi.
The answer is approximately 301.5928.
Happens to be the surface area and also the volume. So that wraps up standard 11B, finishing the review for reassessment day number 2.